Hi and welcome to the last section of this course, continuing with intelligent enemies. This last section continues with the previous one and completes the AI project by focusing on the theory and related coding underpinning an intelligent enemy. The enemy will demonstrate three main behaviours: patrolling, chasing and attacking. This section will demonstrate the following topics: how to plan and code an AI system for enemy characters, how to code finite state machines, FSMs, how to create the line of sight functionality. Now we'll see the first video of the last section, Enemy AI, Range of Sight. In this video we'll start developing enemy AI by thinking about our functional requirements. The enemies in the scene will begin in patrol mode, wandering the level from place to place searching for the player character. If the player is spotted, the enemy will change from patrolling and begin chasing the player, attempting to move closer to them for an attack. If the enemy reaches within attacking range of the player, the enemy will change from chasing to attacking. If the player outruns the enemy and successfully loses them, the enemy should stop chasing and return to patrolling again, searching for the player as they were doing initially. This, in sum, describes our needed enemy AI behaviour. To achieve this behaviour, we'll need to code the line of sight functionality for the enemy. The enemy relies on being able to see the player character or determining whether the player is visible to the enemy at any one moment. This helps the enemy decide whether they should patrol or chase the player character. To code this, refer to the following code from the source file linesight.cs. This script file should be attached to the enemy character created so far from the previous section. The linesight class should be attached to any enemy character object. Its purpose is to calculate whether a direct line of sight is available between the player and the enemy. The canSeeTarget variable is a boolean, true-false, which is updated on a per-frame basis to describe whether the enemy can see the player right now for this frame. True means that the player is in sight of the enemy, and false means that the player is not visible. The field of view variable is a floating point value that determines an angular margin on either side of the enemy eye point, inside which objects, like the player, can be seen. The higher this value, the more chance the enemy has of seeing the player. The inFOV function returns true or false to indicate whether the player is within the enemy field of view. This ignores whether the player is occluded behind a wall or solid object like a pillar. It simply takes the position of enemy eyes, determines a vector to the player and measures the angle between the forward vector and player. It compares this to the field of view and returns true if the angle between the enemy and player is less than the field of view variable. In short, this function can tell you whether the enemy would see the player if there were a clear line of sight. The clear line of sight function returns true or false to indicate whether there are any physical obstacles, colliders such as walls or props, between the enemy eye point and the player. This does not consider whether the player is within the enemy field of view. This function, in combination with the inFOV function, can determine whether the enemy has a clear line of sight to the player and is within the field of view, and thus whether the player is visible. The onTriggerStay and onTriggerExit functions are called when the player is within a trigger volume surrounding the enemy, and when the player leaves this volume respectively. As we'll see, a sphere collider can be attached to the enemy character object to represent its horizon of view. This means the total distance or radius inside which the enemy could see the player, provided they were within the field of view and a clear line of sight existed. Now, attach the linesight.cs script file to the enemy character in the scene as well as a sphere collider component, marked as a trigger, to approximate the viewing horizon of the enemy. Leave the field of view setting at 45, although this can be increased if needed to around 90 to tweak the effectiveness of the enemy viewing range. The eye point field is by default set to none, which represents a null value. This should refer to a specific location on the enemy character that acts as the eye point, the place from which the character can see. To create this point, add a new and empty game object to the scene using the application menu, Game Object, Create Empty. Name the object eye point. Activate its visibility from the inspector using a gizmo icon so that it can be visible even when deselected, and add it as a child object to the enemy. Afterward, position the object to the character eye point, making sure that the forward vector is facing in the same direction. Now, drag and drop the eye point object from the hierarchy panel to the eye point field for the line sight component in the inspector. This specifies the eyePoint object as the eyePoint for the enemy character. This will be used in determining whether the enemy can see the player. Having a separate eyePoint object like this is useful as opposed to using the character position, which is typically at the feet location and not the eye. Finally, the line sight script determines the player location by first finding the player object in the scene using the player tag. Consequently, make sure that the player is tagged or labelled using the player tag. Now take your game for a test run. When you approach the NPC object, the Can See Target field will be enabled. Good work! The line of sight functionality is now completed. Let's move on. In the next one, we'll learn about finite state machines.